divided into two parts. These two parts are equal as per theorem. So now let's take the angle made by the sector is theta. So if it is bisecting this if it is bisecting the segment, it's nothing but cot PQ. Then it bisects also the angle. So if it is theta, it's divided into two parts. That is theta by 2 and theta by 2. So let's take from triangle OPL. OPL is a triangle. From this, if you have taken theta, angle is theta by 2. Let's draw this. If we draw in this manner, we will take this triangle using the symmetry, rotational symmetry. Then we rotate this triangle theta by 2 here. This is theta by 2. And this is O and P L. So here, opposite side is PL, where it is 90 degrees because we know it makes 90 degrees with the segment. It's because it is a perpendicular bisector. So 90 degrees. Using trigonometry, we can find out the sides. That is, sin theta is equals to the relation between the sides is opposite side by hypotenuse. That is PL divided by OP. Sin theta is PL divided by OP. And when we take the cos theta is equals to adjacent side by hypotenuse. Adjacent side is OL by hypotenuse is OP. So here, let's take OP to left hand side. So OP into sin theta is equals to PL. The first one, let's take this one also. So OP into cos theta is equals to OL. PL and OL we got here. So PL and OL is height of triangle and PL is one of the part of a triangle or the base of the part. So we need to get one more part. So PL and LP is nothing but PQ, but we know that the line which is drawn from center to the segment, center to the chord, it bisects the chord. So PL and LQ are equal. So if we take in the place of PL is equals to 2 times of PL. If we take 2 times of PL and then 2 times of OP into sin theta. So 2 times of PL is nothing but we have taken 2 times. The reason is we need to find out PQ. We multiply 2 on both sides of this. So let's take that. 2PL is nothing but PQ because these two parts are equal. So 2PL is PQ and 2 into OP sin theta. We are there. OL is directly we can write. So from this diagram, so OP is nothing but from center to any point in the circle is called as radius R. So let's take OP place R. So 2R into sin theta is equals to PQ. So 2R sin theta we got here, and OP also we can take R in this place. So R into cos theta is equals to OL. So we got OL and PQ. The reason of finding OL and PQ are Here, base of this triangle OPQ is PQ and height of triangle OPQ is OL. So we can find out the area of a triangle of this. So let's find out area of a triangle OPL. Let's find out the area of a triangle OPQ. Triangle OPQ is equals to half into base into height. So half into base of a OPQ is PQ into height of this is OL. So half into base PQ is 2R into sin theta. OL is R into cos theta. This is triangle OPQ. So after cancellation of 2 here, then we'll be getting, there is R is present, here R is present, so R square into sin theta into cos theta. This is triangle OPQ. So now we got area of a triangle OPQ, that is R square into sin theta into cos theta. So when we got this, let's write in this place, that is R square into sin theta into cos theta. So area of a sector, we know that there is a formula for area of a sector, theta by 360 degrees into pi R square. So from this 2 you can observe there is a common of R square. So let's take common R square. When we take R square in common, so then we'll be getting pi theta by 360 minus sin theta into cos theta. So this is R square. Area of a segment PQR. The segment, area of the segment is equals to, we got after subtracting these two figures, that is R square into pi into theta by 360 minus sin theta into cos theta. In this we can observe that angle is formed is theta by 2. So when we consider sin, value for this sin theta by 2 is equals to opposite side by adjacent side, opposite side by hypotenuse. This opposite side is PL divided by PO. And when we consider cos value here, cos theta by 2 is adjacent side OL by PO hypotenuse. So let's see, here PL is nothing but one of the part of a chord. So this is one of the chord and this chord is drawn. Chord is bisected by the line OL. So PL and LQ are same in this. So PL is equals to LQ. So then we can take here OP or PO into sin theta by 2 is equals to PL. When we transpose this one also, PO into cos theta by 2 is equals to OL. So when we find out PL, 2 times of PL, we'll be getting PQ. Just now we have discussed a line drawn from center to a point, it bisects the point. We know that line drawn from center to the point, it bisects the point. So it becomes 2 parts. So when we take and we multiply by 2 on both the sides of this equation, we will be getting 2 times of PL. 2 times of PL is nothing but PQ. So multiply by 2 into PO into sin theta by 2 is equals to 2 times of PL. 2 times of PL is nothing but PQ. So write PQ this place. So 2 into PO into sin theta by 2 same as it is, we can write it. So but we can observe that OP or PO is radius of the circle. So when this OP we are taking as radius R, OP or PO is equals to radius of the circle. So 2 times of the radius of the circle into sin theta by 2 is PQ. And here when we substitute in this place, this is equation 1 and this one, PO is R into cos theta by 2 is OL. The second equation. So from the first and second equations we take and find out the area of a triangle OPQ. Triangle OPQ is nothing but half into base into height. Half into base into height. Here half into base. Base of this triangle is PQ. PQ is nothing but 2 into R into sin theta by 2. And OL is the height. Height is equals to R into cos theta by 2. So here area of a center. So because we are substituting area of a triangle OPQ, and now area of a triangle, area of a center OPRQ, we are subtracting this both and we'll be getting the area of segment PQR. So let's substitute in this place. That is area of a sector OPRQ. Formula is theta by 360 into pi r square. So the same as it is, we are writing theta by 360 degrees into pi r square. So from this we can observe there is a 2. Let us cancel 2 in this. So after cancellation, seeing this board, we can simplify this part, that is R value into R into R square into sin theta by 2 into cos theta by 2. So this side we got theta by 360 degrees into pi r square. So we can observe in this 2, that is r square, and we take r square in common. So we will be getting, we have taken r square in common, then pi will be left out, pi into theta by 360 degrees minus, we have taken r square in common, then sin theta by 2 into cos theta by 2. So this is the area of a segment.